Welcome back. This is lesson 7.8 journal, part 1, math properties. I will be able to identify different math properties and use them to simplify algebraic expressions correctly. So we've got a few that we are going to write down. So please get out your second vocabulary page for the chapter 7. Okay, we've got, first thing we're going to do is write to simplify. To simplify an expression is to minimize to its smallest and simplest form. To summarize to its small and simplest form. Alright, commutative property is the property that states that the terms can be moved around and still be terms or factors. Let's write that, because it can be terms meaning it can be added, or factors meaning it can be multiplied, can be moved around and still be equal. It only works with addition and multiplication. Example: A times B is equal to B times A, or 1 plus 2 plus 3 is equal to 3 plus 1 plus 2. Everything's moved around, but they are equal to each other. Okay, the associative property is the property that states that the grouping symbols can be moved around. And still be equal. So it only works again once with addition and multiplication. So an example of that, let's say we had 3 plus 5 plus 7, but 3 and 5 are added together first. That states that if I decided to move the grouping symbols and put the 5 and 7 together first, we could do that if we wanted to. Okay, it also works with timesing, so let's say we had A times B times C. We wanted to do A and B together first, we could put B and C together. Notice that my order is not changing for my factors, it's just the grouping symbols. Okay, the identity property is the property that states that any number variable will stay the same if you add 0 or multiply by 1. So example, A plus 0 is still going to be A, or A times 1 is still going to be A. Okay, the 0 property is the property that states that any number multiplied by 0 will equal 0. Example, 10 times 0 equals 0. Okay, that's going to be all we're going to write on this page, so you can put that away if that's all filled out. Oh, I'm sorry, we have one more that we're going to talk about, equivalent expressions. So you can skip down to the bottom for this one. Equivalent expressions. They are expressions that are equal to each other sorry, I should have read that better. They do equal each other. Expressions that are, I think I wrote something wrong here. I know what I'm trying to say. Expressions that are, I think this blank isn't supposed to be here. The same, oh, I know what it was supposed to be. Exactly the same. So, expressions that are exactly the same when simplified. Okay, so they can be written differently, but are still equal. Example, if I have A plus A plus A, that's exactly the same as 3A. Those are equivalent expressions. Okay? Alright, now let's go back to our page. So we've talked about all the different properties and written down their definitions. So we are going to decide if each statement is true or false. If it is true, state what property makes it true. So looking at this, we're going to figure out if these are equal to each other. So 2 times 3 is 6. 6 times 7 is 42. Well, if I do this over here, 3 times 7 is 21. Then 21 times 2 is going to give me 42. So they are equal, yes. True. Now, what property makes them true? What's happened differently from here to here? Well, these are out of order compared to each other. So, because they are out of order, the property that makes this true is the commutative property. Commute means to move. Alright, let's try this one. 18 divided by 2 is 9, plus 1. Give me 10. If I do this, they move the parentheses on me, so this gives me 3. 18 divided by 3 is 6. Are they equivalent? No, that would be false. Why does this not work? Because this is a combination of division and addition. It has to be all addition or all multiplication for the associative property to move. So even though they move the parentheses, it does not keep it true, so that would be false. Alright, let's try this one. 8 times 1 plus 2 is equal to 8 plus 2. So 8 times 1 is 8, and 8 plus 2 is 10. 8 plus 2 is 10. Okay, so why are these equal? What property has been applied here? The only thing that's different between this one and this one is 8 was multiplied by 1. So which property talked about when we multiply something by 1, it stays the same? That would be our identity property. It keeps its identity even after being multiplied by 1. Alright, let's try this one. 18 minus 2 plus 1. 18 minus 2 is 16. 16 plus 1 is 17. 2 minus 1 is 1. Plus 18 is 19. So these are not equal to each other. We switched around the order and they weren't equal. That's because there's a subtraction in there. So this is false. The commutative property does not work if you have subtraction. Alright, let's try this one. What is done differently here? It looks like the grouping symbols have been moved. Their order is the same, but this grouping symbol's on the 8 and 7, and this one's on the 3 and 8. Let's see what happens. 8 plus 7 is 15. 15 plus 3 is 18. Well, 3 plus 8 is 11, and 11 plus 7 is 18. So what does that tell us? They are equivalent to each other, so that's true. And this would be the associative property because the grouping symbols have changed. Let's try this one. 14 minus 0 plus 3 plus 0 equals 14 plus 3. Well, 14 minus 0 is 14. Plus 3 plus 0. 17 plus 0 is going to give me 17. This gives me 17, so yes, these are equal. What property is happening here? Well, if I minus 0, it didn't change 14. If I add 0, it didn't change 3. So this would be the identity property. We've done something to it, and it hasn't changed its identity. That's why one side is still equal to the other. Okay, let's look at this one. It looks like we have an order change. 3 plus 4a is still in the parentheses, but they've switched around their order. So let's see what happens. 3 plus 4a I can't combine, but I can combine 2a and 4a. So that would be 6a plus 3. Here I can't combine what's in the parentheses, so, but since it's all addition, I can do 2a plus 4a, gives me 6a plus 3. They're equivalent to each other. Well, they simplify to become the same exact thing. So this is true. Now what property has happened? If we switch around the order, that would be the commutative property. Okay, how about this one with variables? We have 13x plus 4y plus 3x. Now we put 4y plus 13x in parentheses. So what's in parentheses is different. Their order is not. Oh no, the order is different. We've got grouping symbols and look at that. Our order is different. Let's see if they're equal. So 4y and 3x I can't put together because they're not like terms. But I can put 13x and 3x together since it's all addition. So that would give me 16x's plus 4y's. Over here, I end up with 4y's and 16x's. Now these are just flipped around, but the commutative property states those are equivalent to each other. So yes, these are equivalent. Now this one used both the commutative property and the associative property. Because they move the grouping symbols, they also move the order of the numbers around. Alright, so here fill in the blank to make it true and state the property that makes it true. So 4m plus 7 is equal to what plus 4m? That would be a 7, and what's different here? Our order is different, so this would be the commutative property. Okay, 3D plus something gives me 3D. Well, I can add 0 and get the same thing. So what property would that be? That would be the identity property. It maintained its identity even after adding 0 to it. So here we have 3 plus 2 plus 4 in parentheses. They switched the parentheses, the 4 is outside the parentheses, so this would have to be a 3. So what property would this be? This would be the associative property because we are switching the order of the parentheses. So we move the parentheses, different group. 5k times something gives me 0. Anything times 0 gives me 0, so this would be the 0 property. Alright, down here says use the commutative property to rewrite each expression so that the like terms are next to each other, and then the associative property to group the like terms together. So, commutative property, if I want to put like terms next to each other, this is all addition. So using the commutative property means to move the terms around. So I can put 3m plus 4m together. And I can put 7 and 1 together. Now the associative property means I can put the grouping symbols other places. So I'm going to group 3m plus 4m plus 7 plus 1. Now the simplified expression, put together our like terms. 3m plus 4m would be 7m's total. Plus 7 plus 1, that would be the same as adding 8. So the simplified expression, oops, can't see that, sorry. Simplified expression would be 7m plus 8. So in this one, put our like terms together. If I want to move 4z over, I could put that, so 16 plus 4z plus z. We've used our commutative property to move things around. Now I can use the associative property to group any of these together. So I'm going to group 4z and z, saying I'll put those together first. Now to simplify it, that would give me 16 plus 4z and one more z would be 5z's total. Alright, let's use the commutative property here. We've got a bunch of addition going on. So I can put my k's together and my g's together. So I'm going to put 12k plus 3k, use the commutative property and move 9k next to that. And then I can put 5g plus g here. So these can all be, oh, that would be the next spot, sorry. So I can put 12k plus 3k plus 9k together. And I can group 5g plus g together. So these all together, 12 plus 3 is 15, 15 plus 9 is 24. So 24k plus 5g plus g would give me 6g. That's using the properties to help you simplify expressions. Okay, rate yourself on this concept, 0, 1, 2, 3, or 4. Take a picture and turn it in on Google Classroom.